More administration tasks. In this nugget, we're going to continue our discussion of administration tasks in Linux. We'll start by talking about system logging and learn how to configure the system logging functions to record the information that you want for the various facilities in Linux. Then we'll talk about utilities that are available to us that allow us to schedule tasks to automatically occur at some future time. And then we'll talk a little bit about backup strategies, and we'll wrap up by looking at how to set the clocks in your Linux system. Let's get to work. Let's start out this nugget by talking about system logging. And the first thing that I want to do is I want to go up to the etc directory and check out syslog.conf, which is the configuration file for the system logging routines. All right, so let's take a look at this. And you can see the first thing at the top of the file, it says, for more information about the format of this file, check out the man page for syslog.conf. We'll look at that man page together in a couple minutes. First, I just want to show you the general structure of the syslog.conf configuration file. So basically, there's all of these different facilities in Linux. There's errors relating to the kernel. There's errors relating to the mail system. There's errors relating to general user logs, things like that. Okay, and all of these different facilities can have their error messages placed in different log files, so it's easier for you to sort out something. So if something's wrong with the mail system, you know which logs refer to the mail system, and you can go to those logs and check things out to debug what's going on with the mail system. All right, not only can you separate out log messages based on the facilities that they refer to, but you can also separate out log messages based on the importance of the log message. So is it just some sort of information log message, or is it some kind of an error, or is it some kind of an actual emergency, like something's been hacked into, or something like that? So let's page down through this syslog.conf configuration file and take a look at one of the easier ones to understand. And this all relates to the mail system. All right, but all the other ones that you'll see down here for news and the kernel one that we just passed by, they're all kind of the same. So basically, the first field here before the period relates to the facility that we're logging. So in this case, the mail system. Then there's a period, and then there's the level or the priority of the message that we're talking about. So the first thing that we do in this particular example is we say mail.star. So all log messages related to the mail system will get put into the var log mail file. All right, then there's like the info messages, which are not very important messages. They're going to get put into varlog mail.info. Mail.warn is a little bit more important kind of a message from the logging system, and so that gets put in its separate log file mail.warn in varlog. And then there's the most important one that we've categorized here is mail.error, and that goes to varlog mail.error. All right, you can see there's a dash in front of these three, and there's no dash in front of this last one. The dash actually increases the speed that the logging is done by not syncing up the log file after each write. The danger with that is that you might lose some important log messages in the case of a system crash. The general rule of thumb here is that for very important messages like error messages, then we don't want to sync up because then we want those error messages. We don't care if these error messages take longer to write or they slow things down, because hopefully we're not getting a lot of these messages. Whereas these kinds of messages, we might be getting a lot of them, and they're not really that important. And so, you know, we don't care if we lose some here and there, if we drop a message here and there in the event of a system crash. All right, so now let's just take a look at the syslog.conf man page. Okay, so in this man page, it tells you all about the configuration file. Let's page down a little bit so you can see all the different facilities that we can log. And so all these bolded words here are all different facilities that we can log information about. And when we were gazing through that that configuration file, we saw kern and mail, but there's also cron for the cron system that we're going to learn about a little bit later in this nugget, and LPR for line printer information. Okay, and then if we page down farther, oops, I missed it. If we page down farther right here, you'll see the priorities that you can assign. So there's all these different priorities, the least important being debug and then info, and then we go up to the most important being error and then crit and alert and emerge. Okay, notice that a few of these keywords have been deprecated and shouldn't be used anymore. The other thing to notice is that all the messages of a specified priority and higher are logged according to the action specified in syslog.conf. So what that means is when we were just looking at the mail system, there was only sort of 3 levels in there. There was mail.info, mail.warning, and mail.error. All right. And so if some mail message came along that was of critical importance, it would be logged in the same place that we put the error messages. So the way that we separated it out in syslog.conf was we sort of had 3 classifications, like not very important, medium importance, and very important. All right, so you can separate it out however you want. If you want a different log file for every single different priority, well, you can make that happen and just add the requisite lines to syslog.conf. Or you can choose to put them all into one file because you don't care about all the different classifications. You just want them all thrown in the same file. Or you can do it like I just showed you in the example on my SUSE machine where there was sort of 3 levels. So there was like the least important, the medium importance, and the most important. Now, depending on what information you choose to log on your system and also how much traffic there is on your system relating to, the mail services or web servers or whatever, the log files can grow to be really large. And so you're going to want to rotate them out once in a while. And the configuration file that governs that is called logrotate.conf. All right, so this logrotate.conf configuration file is what the logrotate command looks at when you use that to rotate logs. And the information in this configuration file governs things like how often you want to rotate your logs, how many weeks worth of backups you want to keep, how many, whether you want to compress your log files, and if you want to use bzip2 to be the compression utility, those sorts of things. So this configuration file governs the logrotate command, and if you look at the man page for logrotate, then you'll see all the different directives and things that you can put in logrotate.conf. If you page down to the bottom, you can look at the different options that you can specify for logrotate. And here, down at the bottom here, is an example logrotate configuration file. And this one is a little bit different than the one that we just looked at, the default one for SUSE. And so you can just page through this and sort of get an idea how you want to rotate logs, what kind of logs you want to rotate, what kinds of directives you want to put in the configuration file to do log rotation. And don't forget, the reason that we keep all this logging information around is so that we can check out the log files when there's some problem with our system. So it will help us track and troubleshoot problems in our system by examining the log files. One of the log ways to get at information at log files is with the dmessage command. Dmessage keeps track of all the messages that get printed when you're booting up your system. So a lot of times when you boot your system up, all these messages get printed to the screen, but they scroll by really quickly and you don't get to actually read them at the time. Well, you can always go back after the fact and read them with the dmessage command. I can pipe that through less so that I can see all the different messages that got printed out. And then that's useful if some piece of hardware isn't coming up on my system, isn't functioning properly. I can go back to the boot messages and see if there was some error message at boot time relating to that particular device. Another useful command is the tail command. So the tail command allows me to look at the very last lines of a particular log file. So here in this case, I'm looking at the CUPS, the printing system's error log, and there are the last 10 lines of this file. And the last 10 lines are useful, right, because log files get printed sequentially, and so the very most recent entry in the log file is the very last line of the log file. And there's also the tail-f command, which allows you to track a log file as it's getting printed to. So -f stands for follow, and here it will print out the last 10 lines of the log file, but notice I don't get a prompt back. So what would happen right now is if there was some error message being logged to this error log file, then that error message would be logged to that file and it would also be printed out to my screen. So this gives me a dynamic way to monitor the log file and what messages are being printed to it. Now let's talk about a couple commands that we have at our disposal that allow us to run jobs in the future. So the first of these commands is the @ command. And if we look at the man page for @ you'll also see a listing in here for the batch command. And batch and @ are very, very similar commands. They basically do the same things. They allow us to run some set of commands at some future time that we specify. So let me quit out of here and just show you the simple syntax for the @ command. You can actually specify times in a number of ways for the @ command. If you want to do something crazy like 4 days from now at 3:30 in the morning run this program, then consult the man page for how to set that up. If you just want to do something simple like schedule a job for 3 a.m. this morning, you can say @03:00, hit enter, and then you get the @ prompt, and then you can just type a set of commands here that will all be executed at 3 in the morning, preferably when nobody's on the system, right? So you're trying to schedule this job at some future time because you don't want to degrade system performance while a bunch of people are using the system, like during the 9 to 5 workday or something like that. So what you would do here is you type the commands and hit Control D. I'm just going to hit Control C to get out of here. Batch works the same way. The difference with the batch utility as opposed to the @ utility is batch will run the jobs, if you specify a time, it'll run the jobs after 3 a.m. as soon as the system load is quote unquote low. All right, so batch is monitoring system load, and when the system load is low enough after the given time, then the commands will be executed. So it's just like a little bit smarter than @ in some way, just to make sure that we're not going to inconvenience anyone when we run these jobs. There's also a file in the etc directory called @.deny, and @.deny, you can, as a system administrator, you can list users in the @.deny file, and they will be disallowed from using the @ utility. You can also create a file in the etc directory called @.allow. Instead of denying users on the system, maybe you only want to allow like a few users to use the @ utility, then you can create a file called @.allow and just list the users that are allowed to use the file. So whichever list is shorter, the deny list or the allow list, you can create a file for either one of those depending on what your needs are. Now the cron utility is a little bit different. The @ utility and the batch utility would run a set of commands, but it would only run once. All right, whatever time we scheduled it for, like 3 a.m., it'll run those commands once. And if the system happened to crash or get turned off before 3 a.m., @ and batch won't run those commands at all. Now the cron utility, on the other hand, is a daemon. It's a system process that kind of runs in the background, and it wakes up every once in a while to see if there's any jobs that it needs to run. And if there are jobs that it needs to run, then it will execute them at that time, and this runs every minute that the system is up. So I could schedule a job now to run at 3 a.m. every day, and even if the system crashed between now and 3 a.m., as long as the system came up again before 3 a.m., that job would run. Now, just like the @ utility, the cron utility can be run by normal users or by the root user. And just like the @ utility, you can create files in the etc directory called cron.deny or cron.allow that are lists of users that are denied or allowed to use the cron utility. Let's take a look at some of the files that we have in the etc directory for the cron utility. Now the files that are in the etc directory are for the system-wide cron program. Okay, so like for the root user. So the cron tab here is the important file, and this is the table of jobs that the root user will run at some regular interval. Let's take a look at this cron tab file for a minute. So this cron tab file, it starts with a series of environment variables, okay, and assigning environment variables, and then it has some regularly scheduled jobs here. Now the very first one here, what this does is it tests for the existence of this program called run crons. All right, and if that program exists and it's executable, then it's going to go ahead and run the program, and then it's going to pipe all the output of the program to dev null. Dev null is just a black hole where we pipe the output there because we don't want it to show up on any screen or anything like that. And the programs themselves should take care of logging information. So the programs that are run by the run crons script here, those programs should have logging information about, what succeeded, what didn't succeed, that sort of thing. Now, the nice part about the way things are set up in SUSE Linux and Red Hat Linux is if we do a listing again of the cron stuff in the etc directory, there's already a series of directories here called cron daily, cron hourly, cron monthly, and cron weekly. And inside of these directories, you can put scripts, and those scripts will run on a daily, hourly, monthly, or weekly basis. So that takes care of most things that you need to do as a system administrator. Either you want to do something daily or hourly or monthly or weekly. And all you have to do then to do that is put a script into one of these directories. Let's now talk about what a normal user would have to do to get some job to run at some regular interval. If a normal user wants to run a job at a regularly scheduled interval, they can't put their jobs into the etc directory cron hourly, cron daily, cron weekly subdirectories. They're reserved for system tasks. All right, so if a regular user wants to run something at some regular interval, then they have to edit their own cron tab file, and the way they do that is write cron tab -e for edit. So you can see here, I don't have any entries in my cron tab file now, but I'm going to show you how I can edit this cron tab file. By default here, we're in the VI editor. So remember your VI commands, I for insert, and now I can start typing what I want. So the first 5 fields of this entry are going to be time and date fields. I'm going to specify the time, the day, the month, the day of the week, the hour of the day, the minute of the hour, and so on for a particular job to run. So just say I want to run a job at 1:15 in the morning every day of the month. How would I do that? Well, I would say 15, because the first field is for minutes. The next field is for hours, so that's 1. The next field is the day of the month. If I want to run it every day of the month, I can just write star there. The next field is the month of the year. If I want to run it every month of the year, then I'm going to write a star there. And if I want to run it every day of the week, I'll put a star there. And then I can just specify the script name that I want to run. I'll just make something up here, test.sh. Okay, so this script, test.sh, will run at 1:15 in the morning every month of the year, every day of the month, every month of the year, every day of the week, and at 1:15 in the morning. Okay, so that's one thing that I can do. Let's talk about some other notation that we can use in here. Say I want to run something on the 1st and the 15th of the month at 12:30 at night. Well, how would I do that? Well, I would say 30 minutes past the hour. The hour at 12:30 at night, like 12:30 a.m., the hour would be 0 because we're using like military time, okay, 24-hour time notation. And then if I want to run it on only the first day and the 15th day of the month, I would do 1:15. I would do it for every month of the year, every day of the week, and then I would write the name of the script. Okay, so there's my second entry. So this would happen at 12:30 a.m. on the 1st and 15th of every month. Say I want to run something only on Sundays at 3 in the morning. How would I do that? Well, I would say the 0th minute on the 3rd hour, okay, every day of the month, because I'm not specifying which number day that we're talking about, every month of the year, but I only want it to happen on Sunday, okay, at 3 in the morning. So I can either write Sunday here in the 5th field, or I could write a numerical number, like 0 stands for Sunday. Actually, 7 also stands for Sunday. For some reason, the range here is 0 to 7. So it's a little bit of a weirdness. For both the last 2 fields here, the month and the day of the week, you can either specify them with numbers like 1 to 12 for the months and 0 to 7 for the days of the week, and 0 and 7 both represent Sunday, or you can use the first 3 letters of the month or day's name to represent it. So to make it more readable, I always write the day here in letter notation, so Sunday, and then I can give the name of the script that I want to run then. Okay, so to review, this script, test3.sh, is going to run only on Sundays at 3 a.m., no matter what day of the week that is, or what day of the month that is, or what month of the year that is, only on Sundays at 3 a.m. All right, so there's a little explanation of the cron utility, and then what I would have to do here is I would save this :WQ, escape :WQ, and now it says installing a new cron tab, and so those cron programs are now going to be run at those specific times. So cron tab -L, what that is that's a listing of my cron programs, and there's the 3 programs that we just put in there at those various times that we specified. All right, well, now let's move on and talk about backups. First, let's understand the different kinds of backups that you can do to your system. You can do a full backup of your system, which means you're going to back up all of the data on the system. You can do an incremental backup, which is basically, like it sounds like, a small sort of regularly occurring backup of all the data changed since the last incremental backup. So I do a full backup, say, on Sunday. And then I do incremental backups on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Then I can do another full backup on Sunday, say. Now, each of those incremental backups on Monday, Tuesday, Wednesday, et cetera, those backups contain just the data that was changed on Monday. And then the Tuesday incremental backup contains just the data that was changed on Tuesday. If your system crashes on Saturday night just before the next full backup, then you have to do, in order to do the restore, you have to restore the full and then each of the day's incremental backups. Then there's a differential backup, and that is all the data changed since the last full backup. So say I do a full backup like once a month. Well, if I did incremental backups every day of the month and then the system crashed on the last day of the month before I did a new full backup, well, then I'd have to restore from that full backup and like 30 incremental backups. That would be kind of a pain. So a differential backup is kind of like a medium point, okay, for lack of a better word. So I do the full backup, say, on the first of the month. I do the incremental backups all week. Then I can do a differential backup like once a week. And that differential backup will take all the data, sort of summarize that whole set of incremental backups for the week. Then if something crashed on sort of the end of the month, I'd have to restore the full, I'd have to restore a few differentials, and then a handful of incrementals. All right, so depending on your backup strategy, these are the 3 basic classifications that backups can fall into. Now let's talk about what kinds of solutions or backup methods different enterprises or different people should use. So first there's the home user. Now the home user, what do you need to back up, right? You need to back up the Etsy directory because it has all your configuration files. The home directory has all of your, actual user files, books that you're writing, things that you're recording, videos, whatever. That's all in the Etsy and home directory. And pretty much everything else on the system, all of my software and everything like that, I can just reinstall from the distribution CDs. That doesn't take very long. It takes like an hour or something. And so if I just back up Etsy and home weekly, I'm pretty happy with that. Right? And the home user can use a floppy disk to do that backup. They could use a CDRW to do that backup. They could use an external disk drive or a tape drive if they had one. Those sorts of things. But most likely would be a floppy and a CD drive. Now, a small office starts to get into a little more crucial data. So those kind of situations, you might want to do daily backups. And you might want to do something like what we were just talking about, a full backup once a week and then maybe some incremental backups. Depending on the amount of data that you're backing up, you might need to jump up to a DVD drive to burn it to a DVD. A CDRW holds about 700 megabytes, whereas a DVD holds about 5 or 6 or 7 times that. And then if you're in an enterprise situation, you have to remember that data means money, okay? You can't lose this data. So in those sorts of situations, the typical thing is that they use very expensive automated backup solutions, tape drives with like automatically rotating tapes and things like that. So depending on the level of the enterprise solution here, how big the environment is, the bigger the environment is, the more expensive it is, the more money you're going to put into backups. I just want to wrap up our discussion of backups by pointing you to a website out here on the internet, and it's called linux-backup.net. This is a really nice website. It's got a lot of good information about backups in Linux. It goes through a lot of the basic issues that we've been talking about, like for home users, for small office users, for enterprise users. They walk you through all the different commands, exact commands that you can use to do backups to different kinds of media, whether that media is a floppy disk or a CD-RW or a zip disk or something like that. CD drives have special issues associated with them as backup media because you usually can't write to them just like a file system. You have to, pack up a bunch of stuff as a tarball and then write that tarball off to the CD drive. And that way things like file permissions and stuff like that is preserved. They also go through some backup strategies, like how often should you do full backups versus incremental backups. They also concentrate on restore procedures here. And that's one thing that a lot of people seem to overlook when they're developing a backup strategy. They go through this very elaborate scheme and keep track and make sure they've, have an incremental backup of all the things that have changed every day, but they never practice and go through the restore procedures. And one of the problems there is a lot of times there's failures in backups, or there's media errors or something like that, especially if you're reusing tapes over and over and over again for your backups. There could be media errors that crop up on there. So every once in a while, you should practice doing a restore to make sure everything's in line. And also, in an enterprise system, you have to make sure that, backups, like we were talking about before, data is money. And so, if your system's down and you need to restore from a backup, you need to be able to do that in a timely manner. And the only way you're going to be able to do that in a timely manner is if you practice once in a while and you stay familiar with the restore procedure. So all that information is on linuxbackup.net, exact commands and everything that you'll need to do, various scripts and things like that that you can run to do backups on your system. The last administration topic I want to talk about in this nugget is learning how to set the date and time. First of all, there's two clocks in your system. There's a hardware clock that is run on its own independent battery, and when you power off your system, the hardware clock keeps ticking so that the next time you start up your system, you'll have the correct time. There's also a Linux system clock. When the Linux system boots up, it reads the hardware clock, but then it maintains its own time after that. And the reason for that is just because a lot of things in Linux require a current date, and it's kind of a pain to, always probe that hardware and look for that. So when you type the date command in Linux, you're actually looking at the Linux system clock. You're not looking at the hardware clock. If you want to change the date of the Linux system clock, you've got to be the root user. Again, you can use the date command, but this time you just specify the date that you want to set the clock to. And so here, let's just decode what this format means. So 0513 means May 13th, and then 1234 means 12:34 p.m., like 34 minutes after noon. So that would set the current date to May 13th, 12:34 p.m. It would leave the year alone, and it would just set the seconds to 00. Okay, as soon as you hit enter there. I don't want to mess with that because I've got the current date set on my computer correctly, so I don't want to play with that. But if I also wanted to change the year in this format, I could do that. I could say 2005 or something. If I wanted to add seconds on, I could put .30 there to represent the seconds. And there's all sorts of different formats that you can specify the time in. I like this sort of straight ahead format. It's a little terse, but it's always 2 digits for the month, 2 digits for the day, 2 digits for the hour, and 2 digits for the minute. Okay, so once you set your current date on your system, you can also set the hardware clock. You can set the hardware clock, independently, but I like to set the current date to a very accurate time source and then set the hardware clock to this current date. The only reason you'd ever set the hardware clock is if you had your computer turned off for so long that the battery was dying or something and the clock started getting behind or something like that. So a command that you can use to set the hardware clock is in the sbin directory, hardware clock, then you say -sys2hc. So this is saying take the system time to the hardware clock. So the system time I'm saying is correct, and I want to now impose that on the hardware clock. Once you change that, then the hardware clock is updated to the current system time, and then you're sort of caught up. Okay, so there's the two different time format or the two different time clocks in your system, and there's also how to change the date on your system clock and your hardware clock. And just realize that everything that we've talked about in this nugget, from system logging to cron jobs, all that stuff relies on the proper date and time being set on your computer. If you look at some log file and the error message is from 3 days ago or 3 days in the future or something like that, you're going to start scratching your head saying what's going on, and what's happening is because the current clocks are wrong on some computer in your network, the log file entries are bad, and so it's just hard to decipher what's going on. So if you just make sure that all the systems, the computers in your network have the current date and time set correctly, then all the information in the log files and the cron jobs and things like that are going to operate correctly. If you need very accurate timing, more accurate than what you can get by looking at a good time source and then setting your date that way. If you need very, very accurate timing in your system, you can always configure what's called an NTP service. Okay, so NTP stands for the Network Time Protocol, and there's a little how-to here. If you do a search in Linux for NTP how-to, you'll come up with how-to pages on how to configure this service. And basically what happens is you just go out on the internet, you find a few of these servers that are out there that have very accurate time on them, and then your computer will go out and sort of grab that information once in a while and then kind of average the results and do some things like that, so that your computer is constantly up to date with a very, very accurate time signature. All right, well, that's all we have to say for setting the date and time. Now let's just wrap up this nugget. Well, it's time to wrap up our second nugget on administration tasks. We started by talking about system logging. And remember, the important configuration file here is etc syslog.conf. And this is where you can change the information that gets logged, the location of the various log files, and things like that. Then we talked about the utilities that were available to allow us to schedule jobs in the future. Remember that at and batch are both utilities that allow us to schedule a job once. But if we want to schedule a job repeatedly, like every week or every day, then that's a better use for the cron facility. And cron allows either regular users or the root user to schedule a job repeatedly. The root user's cron table is in the file etc cron tab, and this has information about which jobs get scheduled and when they get scheduled and that sort of stuff. And remember, there's also the etc cron.daily, etc cron.weekly, etc cron.monthly directories under the etc directory, and those directories have scripts in them that will execute daily, weekly, monthly, hourly, whatever the subdirectory happens to be. And that's the easy way, without messing with the cron tab, to get a job scheduled on some periodic basis. We talked about backups. We talked about some basic strategies for backups. And then I pointed you to a website out there called linuxbackup.net. And this is a really good resource. It's got a lot of detail, which is what you need to set up a backup system. Talks about the various media and things like that. And finally, we wrapped up by talking about system time. We talked about how to set the date and time on your system, and to do that, you use the date command. There is a command called time as well, but that has nothing to do with setting the system time. It has to do with timing programs for performance reasons. Well, I hope you found this nugget informative, and thanks for watching.